Hello, I'm Dr. Bruce DiNardo here in the Physics Lecture Demonstration Laboratory at the Naval Postgraduate School in Monterey, California. How can a submarine sink or rise? One way is to change the amount of water in the ballast tanks. But how does this cause sinking and rising? We can understand the behavior by considering a simple physics demonstration called a Cartesian diver. Here is our Cartesian diver apparatus. It is a flexible 2-liter soda bottle with an inverted glass test tube inside. The test tube is open and it contains some air. The yellow tape around the glass and the cork in the top there is just so that it can be clearly seen in a classroom. The bottle is filled with water and is securely capped. There is enough air to make the test tube float. Without the air, it will sink. There are different ways that you can make the diver sink. One is by telekinesis, using your mind to move objects. This takes effort and practice. So let me see if I can do it. Does anybody have any questions? I bet you do. While I did this, my hand was on the bottle. Can I sink it without my hand being on the bottle? Let me try. Nope, I can't sink it. As far as I know, there's no scientifically documented evidence for telekinesis. I sank the diver before by squeezing the bottle. Unsqueezing the bottle causes the diver to rise to the top. The apparatus may have been discovered by René Descartes, but the first thorough and printed account was in 1648 by a contemporary of Descartes named Raffaello Maggiotti, who claimed to have discovered it. Maggiotti was a favorite student of Galileo. To understand the Cartesian diver, we first need to recognize something about fluids, which are liquids or gases. In gravity, a body experiences not only a downward gravitational force, but an upward force in addition. This force is called the buoyant force. The buoyant force occurs because the pressure in the fluid increases with depth due to a greater amount of fluid that is supported above. For example, if you go deep enough in a pool, your ears will hurt due to this increased pressure. The pressure increase causes the upward force on the bottom of the body to be greater than the downward force on the top. The net effect is an upward buoyant force. The buoyant force is quantitatively given by Archimedes' law. The buoyant force on a body in a fluid equals the weight of the fluid displaced by the body. From Archimedes' law, the condition for sinking is easy to remember. Sinking occurs when the average density of the body, which is the total mass divided by the total volume, is greater than the density of the fluid, water in our case. Let me set up a very simple example. We're going to have a glass test tube here full of water. So this is our body, okay? And now I'm going to submerge it in water. Okay? If I release it, what's going to happen? The average density of the body is greater than the density of water because the density of glass is greater than the density of water, and it sinks. We can now explain the demonstration. Look carefully at the air in the test tube. When I squeeze the bottle, you'll notice that water comes into the test tube and compresses the air. The water is incompressible here. What compresses is the air. Let's consider the diver to be the glass, the air, and the water inside the diver. The volume of the diver is constant, but when I squeeze the bottle, water enters the test tube, so the average density goes up. Once that average density is greater than the density of water, it sinks by Archimedes' law. In submarines, the ballast tanks are used to increase or decrease the mass while the volume is held constant, just as we have seen with the Cartesian diver. Pumping enough water into the ballast tanks can cause sinking, and pumping enough water out of these tanks can cause rising. The Cartesian diver is an old, popular physics demonstration and toy. The apparatus is simple, and you can make one at home. Googling Cartesian diver yields tens of thousands of results, and there are also many discussions on it in educational scientific journals. Physics lecture demonstrations are always fascinating, and the quest for them never ends. This is the Physics Department of the Naval Postgraduate School, and I'm Dr. Bruce DiNardo. Thank you.